This is a nice start to the Edexcel January 2003 Mechanics Unit 1 paper. This is a AS for the maths video. Now what we've got in question 1, it's just using momentum. We've got these two situations here that obviously follow each other. So in the first situation we've got this truck. I mean, my excellent drawing of a truck as a square, they are quite similar obviously. You would look at that and go, wow, that is a truck. Didn't really need to tell you that, obviously you got that. And we're giving it a truck P. So the original situation you can obviously read in the paper, but I'm assuming you've been quite lazy. Great insulting the viewer to start with. Anyway, great. What we're saying here is we've got a truck P that's got a mass of 2,000 kilograms, obviously that doesn't change. That's initially travelling at 10 metres per second. And we've got this other truck, Q, which is stationary and has a mass of 3,000 kilograms. Stationary just means it rests 0 metres per second. Now these two collide, obviously. Obvious, no way you're going to know that. And then P is left with a velocity we've got to find out. But when we know Q has got a velocity, end velocity of 5 metres per second. So what I've done here, this is, as I said, you know, it's an artistic sketch. It's something I would recommend drawing in the exam. So what you've got here is I've just put the mass of P is M1. So you could write MP, but just make sure you've got masses and the right velocities with each other. So I've called P a mass of M1, and then therefore that's got a U1 and a V1. So the ones that have a little dash of a denotation by 1, so for U1, M1, that's to do with P. Anything that's got a dash of 2, so M2, U2 or V2, that's got a dash, that's for Q. Okay, so we're asked to find out what P is. Now, we need to remember the conservation of momentum, which says momentum never changes. If no outside forces influence the system, which they don't, because there's no one putting a hand up and pulling P away. That wasn't in this original. Basically what that means is the same things that have got to be acting in the first bit will be acting in the second bit. So P and Q act in the second bit. And they wouldn't give you any other situation where that isn't the case, but you just need to know that. Right, so total momentum before equals total momentum afterwards. That's what conservation of momentum says. So therefore you work out what the total momentum is before, equal that to the total momentum afterwards, simplify it down and get your answer for V. So you can either have a go at that now if you haven't got that, or just simply watch what I do. So it's, you could write M1 times U1 plus M2 times V2 equals M1 times V1 plus M2 times V2. It's up to you. Might be a little bit of a waste of time. And then you would write 2,000 kilograms times 10 meters per second plus, now you could write 0, but just to show the examiner that you know where you've got 0 from, it's just 3,000 times 0 meters per second. It's not that much longer. That's equal to 2,000 kilograms times this. We're going to call it V meters per second or V1 meters per second, whatever you want to call it, VP. I don't care. It's not like I'm going to jump through it's not like I've invented a new physics dimension. I'm allowed to jump through the camera and get it. Don't worry, I'm working on that. Anyway, it's just weirdness. But anyway, 3,000, so that's equals plus 3,000 kilograms times 5 meters per second. Okay, to summarise what we've just done there, I've just put the total momentum before equal to total momentum afterwards. I've not calculated, obviously you can calculate each one of them, but the first thing line of working is just to show what the sums are. So therefore, I guess you could just go straight to adding all them two together. You don't need to show what each of the individual sums are, so you can kind of skip out a line really. But you do need to have this kind of working out somewhere on your page or something like that. So obviously this is equal to 20,000 kilograms meters per second. Don't forget that units, because obviously that's 0. That's equal to the 2,000 kilograms times V1 meters per second plus 3,000 times 5, which is obviously 15,000 kilogram meters per second. Okay, so what you do then is you would move 15,000 over, so take 15,000, so 5,000 kgms to the 1, or kilogram meters per second, is equal to 2,000 kilograms times v meters per second. And if you were to rearrange that, so v meters per second equals 5,000 over 2,000, you get 2.5. So you get v1 is equal to 2.5 meters per second. And obviously you need to get the units because the kilograms sort of cancel out that. So obviously that's in kilograms. Okay, right, so that's what we've got there. Now the next part of the question is quite a simple one. It's just really, well that was simple, but it's just understanding really this question. So that was a nice 3 marks by the way, so I'd say 1 for getting the answer, 1 for getting out the right, working out, 1 for simplifying it down, and then 1 for the correct answer. Okay, so anyway, you can work that out from the mark scheme. 1b says the magnitude of the impulse exerted by P on Q. So basically what this is saying is the change of momentum, so the momentum given by P to Q. Now, as Q had no initial, so basically it's the change in momentum of Q. That's what we're saying, okay? The wording is quite confusing, I'll admit, that's probably the hardest bit of the question. I'll understand what it's saying. So if you, just go over it in your head if you still don't get it. The magnitude of the impulse exerted by P, so P is pushing, so you're working out the impulse P is giving to Q, so Q doesn't get any change in momentum from anything else, so therefore the increase in momentum of Q must have been given by P, which is what this is asking for. Now, as the original momentum of Q is nothing, because 3,000 times 0 is weirdly 0, you just can work out the momentum of the second, the after part, so it's just 3,000 kilograms times 5 meters per second, which is obviously 15,000 kilogram meters per second. However, in your working out, because this is worth 2 marks, I would show that 15,000, so you do delta mv or impulse equal to the momentum after take momentum before, subbing 15,000 take 0 just to equal 15,000 kilogram meters per second. So don't forget, so that's what I do, but you could just write 3,000 times 5. It might be a little bit risky. I'm not sure if the math scheme doesn't allow that now. Oh wait, yeah, 3,000 times 5, sorry. I did say that. Yeah, the 3,000. Yeah, the mark scheme just allows you to do 3,000 kilograms times 5. But personally, just because you might get an arse of an examiner, I would just do what I said when you do change momentum to momentum after take momentum before, and just give you an end answer, 15,000. Okay, so that's quite a nice 5 questions there of 70, isn't it? The next question is a little bit more tricky, but it's just a case of understanding what the question is saying. Anyway, so we'll go into that in the next question. So thanks for watching. Hope you've managed to survive it, and don't forget to let me know what you think, as long as it isn't to tell me to get lost, as I normally say. So anyway, I've done a majority of questions like this, but I'm more than happy to, as I said, create some questions similar, so you can have a go at them, and I'll say take them in, or teach you, you know what I mean, just have a look at them, and anything that you get stuck on in any exams, please do let me know, and I'll try and help you. So thanks for watching, and we'll see you in the next video.